Hello guys, and welcome to this session today. In today's session we shall be looking at the correction of the Cameroon Northwest mock their further maths paper 2, the first question 2024. So we shall be looking at it along. It is based on differential equation, guys, and please, just for a quick reminder, if you're new to our channel and you've not subscribed, please just hurriedly hit the subscribe button right now and just press the notification icon such that each time we upload videos you'll be the first person to be notified. And guys, please give the video a like, because that also motivates me enough. It actually tells me that you actually found content like this so useful, and I'm going to do that for you guys. And best of luck to all those who are taking further mathematics in June. Best of luck to all those who are also taking calculus and so on. Best of luck to all of you. Best of luck to all my students I taught them in Yaoundé. Best of luck to everyone taking who is writing mathematics in general, who is writing the sciences. Best of luck. So guys, let's dive straight into our video today. In today's video they've said that by using the substitution v squared equals y or otherwise, we show that the differential equation dy by dx minus 4y times the tangent of x, which is the same like 2 times y raised to the power 1/2, can be transformed into the differential equation dv by dx minus 2v times the tangent of x equals 1, where v is a function of x. Then the next part is saying that hence we should find the solution of the differential equation dy by dx minus 4y times the tangent of x equals 2y raised to the power 1/2 in the form y equals f of x, given that y equal to 1 when x is 0. Okay guys, let's start with the first question. Let's keep in mind that if v squared is equal to y, that therefore means that if we take the square root on both sides, we are simply going to have our v to be the square root of y. Good. So if we have our v squared to be y, that therefore means our v is y raised to the power 1/2. Therefore means if we differentiate this guy now, we are simply going to have 2v. Keep in mind that we are differentiating with respect to x. We are going to have 2v dv by dx, which is the same like differentiating y with respect to x. We simply have dy by dx. Good. Now guys, we are going to substitute this whole equation now into our original equation. So here is dy by dx. We are simply going to replace it with its value, which is going to be 2v dv by dx. So by doing that, we are simply going to have 2v dv by dx minus 4y. What is our y? Our y in this case is what? V squared. That's why the v squared is here. Then we have the tangent of x, which is the same like 2 y raised to the power 1/2. Y raised to the power 1/2 here was what? V. That's why the v is here. So now if we divide all through now by 2v, guys, our proof just comes out. We simply have our dv by dx minus 2v times the tangent of x equal to 1, as required, guys, as required. So that is what the proof, that's exactly all what we needed to do. Okay, now the next part is saying that hence find the solution to the differential equation dy by dx minus 4y times the tangent of x equals 2y raised to the power 1/2 in the form y equals to f of x. These are the conditions that have been given. Okay, now guys, the question wants us to find the solution of this differential equation. Keep in mind that we are from showing that this differential equation is the same like this one, right? And it can be transformed into what? This differential equation. So guys, it will be so good for us to just proceed with what we had initially. Because the equation said hence, so we must continue from here. And to solve such a problem like this, because this is the same equation, this is the same differential equation, To answer this differential, to solve this equation so well, all we have to do is that we have to use a suitable integrating factor. Keep in mind that this differential equation is not like those ones that are done in pure maths where you can easily separate the variables. In this case, I don't think you can separate the variables. So the best thing for us to do now is to use a suitable integrating factor. Good. Therefore means in the integrating factor, we are simply going to have e raised to the power, or the integral of the coefficient of v here. That therefore means we are going to have e raised to the power, the integral of the coefficient of v is simply -2 tangent of x. So we are going to have e raised to the power -2 e raised to the power the integral of -2 times the tangent of x dx, and -2 is a constant, so we can bring it outside of the integral, and we are going to have e raised to the power -2 times the integral of tangent of x dx. Keep in mind, guys, that the integral of tangent of x is simply natural log of secant x. Is simply natural log of secant x. Good. So this is what we have: e raised to the power -2 natural log of sec x. And keep in mind that sec x is the same like what over cosine of x. Then the -2 now can come in front of here according to our laws of logarithms. The -2 can come up here and make everybody here to be what? Cos squared x. Then the natural log is still there, which can cancel with the e since they are both in functions. So the our resultant integrating factor simply pops out to be cos squared x. Good. Okay, now what next we do? We are going to take this cos squared x and we multiply it by this our differential equation here. We are going to multiply it. By so doing, we can recognize that the left hand side of this our differential equation is going to be exact once we've multiplied it with the integrating factor. Good. So if we do the multiplication now, we are simply going to have cos squared x dv by dx minus 2v times the tangent of x times the cos squared of x, which is the same like cos squared of x. So guys, I see that the left hand side, we could recognize this left hand side as what? The derivative of two functions. What are those functions, guys? As I'm seeing cos squared x, then I'm seeing dv by dx. That's to show that the is actually a product of two functions where they kept cos squared x constant and they multiply by the derivative of v with respect to x to have dv by dt. Then since this is tangent x, tangent is sine over cos. One of the cosines can cancel here, so we are going to have -2 sine x cos x, which is simply the derivative of this our cos squared of x here. So I can recognize this man to be the derivative of v cos squared of x dx, cos squared of x all that on dx. I can recognize this man to be like that because if we differentiate v cos squared of x, we are simply going to have everything here. We are simply going to have what we have on the left hand side here. This is exactly what we're going to have. Good. So now in this case, guys, we are simply going to multiply everybody by our dx so that we can separate the variables now. Keep in mind that on the right hand side, everything on the left hand side, sorry, everything is inside the derivative. So in this case now we are going to introduce now our integral sign, and knowing fully well that the integral of the derivative of something is simply that something. It's simply what is inside of the derivative. So now if we integrate our d into v cos squared x, that is going to translate into v cos squared x. Keep in mind, guys, that from our identity says that cos 2x is the same like 2 cos squared x minus 1. If we make cos squared x the subject there, we are simply going to have cos 2x plus 1 all that on 2. Good. So this is what we have now. If we integrate this guy now, we are simply going to have this is still going to be cos squared x, which is same like integrating this man, the 1/2 comes outside. Integrating cos brings us back to sine, but the reverse chain rule says we should divide by the derivative of 2x, which is simply 1/2. Then we have sine 2x. Integrating 1 in the x world simply gives us what? X. plus our constant of integration c. Now guys, also note that the equation gave us y to be what, 1. If you plug in 1 here, you are going to have your v to be 1. So when y is 1, our v is 1. If we substitute everything into this equation, and keep in mind that our x is also 0. If you put everything in this equation, keep in mind that everything here, sine of 0 is still 0. Everything in this bracket becomes 0. And since cos of 0 is 1, 1 squared is 1. 1 times v, which is 1, is still 1. So we have our c at the end result to be 1. Good. Now, if we bring forth our c to be 1 in this expression and we replace everything, we should expect to have, and we multiply all through by 4, we should expect to have 4v. But what is our v? Our v is what? Y raised to the power 1/2. We are going to have 4y power 1/2 cos squared x, which is the same like multiplying here by 4 simply gives us sine 2x. Then multiplying here by 4, this 1/2 multiplies x first of all before the 4 comes and reduces the 2, the 1 will be 2, so we have 2x here. Then now since our c is 1, 4 times 1 simply gives us 4. Good. So now if we then divide all through by 4 cos squared x, in this case guys, we are simply going to have y raised to the power 1/2 equal to sine of 2x plus 2x plus 4 all that on cos squared x. But the equation wants us to leave our answer in the form y equals f of x. That therefore means that we are going to square both sides now, and we are simply going to have our answer to be y equal to sine of 2x plus x plus 4 all that on 4 cos squared x, all this whole quantity squared. So guys, if there's something that you didn't understand, just feel free to leave it in the comment section, and I'm going to reply to it as early as possible. So guys, please don't forget to like this our video guys, because it's a long way to motivate us to keep producing contents like this. And guys, please don't forget to follow our Facebook page and subscribe to the channel if you want more video. Keep in mind that you can only watch the next video and all our other videos once you're a subscriber. This most of our videos now have been restricted only to us. So guys, please just hit the subscribe button so that you're going to join us in our contents. Thank you very much. Thanks very much for watching, and I hope to see you in the next video. Goodbye.